Thank you very much also to the organizing of this nice conference. So I'm very happy to be here. And well, I will present to you the research that was obtained during cooperation between the National and University Library of Slovenia and the University of Ljubljana and the Institute of Cultural Heritage. Okay. So I'm sure that we all know that copper ions may be present in substantial amounts in various cultural heritage objects. Well, for example, in iron callings, they can be found in substantial amounts besides copper, iron, but also besides zinc, cobalt, manganese, nickel, chromium. And also, I'm sure that you are all aware that we have different copper-based pigments such as verdigris, malachite, which were frequently used to color different maps or also some works of art of paper. The problem is that there are, of course, several invasive or non-invasive techniques such as XRF for identification of copper ions, but unfortunately they are not always accessible to paper conservators, especially in private workshops. So I'm sure that you all came across iron tests that were developed by Neevel at the ICN. So they really allow easy identification of iron ions because you just place a drop of water on test papers, which were there, not anymore. Sorry, where is the light? Here. And then you just press the testing paper against the object that you want to test. And if it changes the color, in this case from white to pink, then you know you have positive test either for iron 2 or iron 3. So he also developed copper tests, but they are still not commercially available. They were described in 2005 between the duration of the iron galling project. Here you can see them on the right side. But during my time as a paper conservator, I also came across that especially in Spain and in Portugal, they are using different tests at Cuprotesmo that are commercially available, but they were actually not designed, not developed to be used on historic objects. And then I also read in a publication by Christa Hoffman that they prepared some test papers according to Hulte, which was already published in 1970. So if you know any other quick tests, please let me know. These are the only ones that I know. But it was important, of course, for wider audience, for conservators, to compare and to evaluate if these test papers really work. So, and for this reason, we tested especially the limit of detection of these test papers, and also we have tested the interferences, because certain transition metal ions can also turn this test positive. And also we have tested these test papers on various samples, either that were prepared in our lab or we have used also some sacrificial, either iron galling manuscripts and different maps. So what was important that we didn't test these test strips only in solutions, but we actually prepared different papers. You can see them here with various concentrations. So we just immersed Wattmann filter paper into various concentrations of copper salts. So first we have used copper chloride, and then we have determined the right concentration of copper ions in the paper. So here we have weight ratio of copper ions in the paper. And then we have also used copper sulfide and used slightly higher concentration. And then we just pressed different test papers against these papers that were prepared. So the first were these Cuprotesmo test papers, which are biquinoline-based papers, and they give positive reaction either with metallic copper as well also with copper 1 and copper 2 ions. Actually, they were designed for different surfaces, but not, as I already mentioned, for cultural heritage objects. So they are initially yellow-white papers, and they turn pink to purple-red in the presence of copper ions. So here we have, you can see here image. First, we always made blank experiments, so we just pressed the test paper against Whatman filter paper, and then here are different colors for different concentrations of copper ions, and we can see here that actually above 0.22 they were positive. The tests were positive. And after drying, in some cases, in very high concentration, they actually turned yellow. So the same was with copper sulfate containing samples. Again, this is quite high limit of detection. Why high? Because, you have to compare it with something. Actually, it corresponds, this value, to mean weight ratio of copper in iron gallings. So we would really need some much more sensitive test papers to be used on cultural heritage objects. And another big problem is that here are the samples. You can see that they really induce strong discoloration on the tested papers, but also on the tested objects. Here are just, we took some samples for the AAS measurements. So another papers that we have tested are the ones that are prepared following the Hultes method, the one developed in 1970. So here the color changes. They are from pale yellow to orange, which is, of course, a problem in cultural heritage objects because, they frequently bleed and you can misinterpret the results, but actually they are based on batocuproin and hydroquinone, which reduces copper 2 and copper 1, 2 copper 1 ions, so it detects both ions. But actually, if you test them on the test papers, they are really very, very sensitive. You can see here that with very low concentration, the changes of color appear from pale yellow to orange. So they are really sensitive, and also they don't leave almost no visible signs of testing, which is of course perfect for the cultural heritage objects, but the changes of color are not really. Then we have Neevel copper test papers. Their color changes are slightly better because they change from pink to light blue, and the active substance is chelating azo-dyes that change color when they bind copper 2 ions. But what happened, that was really confusing because we had 3 different batches of these Neevel's test papers. So the first one is already 20 years old or something, and then he sent me 2 batches of test papers, and the first one had really high limit of detection. And the second batch was much better. Here you see the results for first batch. Actually, it turned blue with quite high concentration. And you can see here with your own eyes that really the testing papers are quite different. One it might be due to different concentrations of the active substance, and another reason might be that actually they are degraded already, because azo dyes, we know that they can be very light sensitive and they degrade during aging. So it's very important that you use fresh test papers. But that was not, I mean, so far so good, but it was not good really after we tested these test papers with other transition metals. As the same as we prepared copper-containing papers, we prepared them with other transition metal ions. So you can see here the results for copper. So all 3 test papers were positive. And then we have here aluminum, nickel, iron, zinc, chromium, manganese, and cobalt. And you can see that while other test papers were negative with other tests, with these papers, the Neevel's test papers were positive even for iron. You can see here I have performed this test 3 times because I was so surprised. Actually, they were designed to be used on iron galling, and they turn blue even if only iron is present in the testing papers. And they are also positive with nickel, cobalt, and zinc. With zinc, actually, if you put this positive test paper in the buffer pH 3, the complex disintegrates. So you know that then that it's not positive with zinc, but with other transition metals, you cannot know whether it is possible due to copper or due to reaction with other transition metals. So we also tested these Hulte test papers in water solutions. Actually, they gave good results. They are positive only if copper was present, but in some cases, in some solutions, we couldn't determine because we know that iron solutions are actually yellow. So just quickly, we will go through results of sacrificial original documents. Well, these documents were also tested with XRF. So we knew that these parts were actually positive for copper from XRF results, so these green parts. And all tests were positive with them, but again with Cuprotesmo test papers. The test left visible signs of testing, and it was the same with some sacrificial manuscripts with iron gall ink. So Cuprotesmo again left visible signs of testing on both manuscripts. And well, I was thinking, how can we avoid positive tests with these Hulte test papers? And it is very important that you always perform a test with blank Whatman filter paper in order to see whether these changes of color are results of positive tests or the results of dye or ink bleeding. So you have to compare the color of the tests with blank experiment and also with blank test to be sure that really this is due to the positive reaction with copper ions. So here is an example. Here is one map that could be tested. So here we have the results. These 2 tests were applied here, and here was only Whatman filter paper, so moisturized Whatman filter paper pressed against the surface, and you can see no bleeding. But here where the yellow area or this beige area is, you can see that the dye bled. So you cannot interpret that as a positive result for copper ions. So if I conclude, well, we have evaluated 3 different tests for copper ions. Cuprotesmo, that was not developed to be used on cultural heritage objects. Another one was prepared according to Hulte's method, and the last one by Neevel. So Cuprotesmo test papers have high limit of detection and could not be used on cultural heritage objects because they may cause discoloration of paper materials. Then the Neevel method works well with fresh test papers that have enough of active substance, but if perhaps the test papers were slightly differently prepared, they gave false negative results, and also they give false positive results with several ions such as iron, zinc, chromium, and cobalt, and therefore could not be recommended for routine use. So Hulte's method offers the lowest detection limit and very high sensitivity, but also you have to prepare it for yourselves. Also has to be freshly prepared. It doesn't show any interferences, but of course with every lighting there is also some drawback. So the color shift from yellow to orange is not really perfect for cultural heritage objects because it might cause confusion. And as already mentioned, the papers should be freshly prepared and also by yourselves, but actually the synthesis is not really complicated. So thank you very much for your attention.